Hello everyone. First of all, a few explanations about CONVIS. The purpose of the cooperative is to promote the economic interests of its members through joint business operations, in particular through the promotion of livestock breeding and husbandry. Tasks to achieve these objectives are in particular: A. The maintenance of herd books and hybrid registers. B. The organization of performance tests. C. To advise and train members and customers in all matters relating to the breeding, feeding, keeping, and care of livestock. D. The organization of exhibitions for members. E. Protecting the interests of livestock breeding and production in every respect. F. The creation of a good relationship and fruitful cooperation between the cooperative and agriculture in general. G. The implementation of all necessary measures, as well as the creation of necessary facilities and equipment in order to achieve the statutory objectives. H. The operation of breeding and insemination stations. The following tasks have been outsourced to the subsidiary CONVIS: the organization of brokerage, auctions, and the purchase and sale of all types of breeding, productive, and slaughter livestock, as well as the procurement, storage, and reproduction of good breeding animals, in particular by means of artificial insemination, embryo transfer, and other biotechnologies. Here is the organizational chart of CONVIS. The Board of Directors is responsible for general administration. The management of the Board of Directors includes all necessary factual and organizational measures that serve to fulfill the tasks of the cooperative as defined in the Articles of Association. The tasks and powers of all committees are defined by the Board of Directors in rules of procedure. In principle, there are 4 departments: advisory activities, under which the CSA project has also been handled, has had a separate department for several years, and in principle, all members of the other departments are automatically members of the advisory department. All agricultural productions need different advice in one way or another.
Luxembourg was historically divided into 3 districts. 1. Luxembourg. 2. Dykirch. 3. Grevenmacher. These districts were administratively abolished in 2015 and no longer have an administrative function. Luxembourg is still divided into 12 cantons. Each canton consists of several municipalities. A commune is the smallest administrative unit, and each commune can comprise several villages or towns. There are a total of 102 municipalities in Luxembourg. Luxembourg is a relatively small country in the heart of Europe. It stretches about 82 kilometers in length from north to south and about 54 kilometers in width from west to east. This makes it much smaller than most of the other CSA partner countries. The country has a varied landscape with plateaus, wooded hills, and deep valleys, especially in the Mullerthal region, which is often referred to as Luxembourg's Little Switzerland. Luxembourg has a temperate climate with mild winters and often pleasant summers. Recently, however, there have been clear special effects. For example, several summers during the coronavirus years were very dry and very warm. Last year, 2024, the weather situation turned into the exact opposite. It rained at record levels for almost the entire year. As a rule, it rains a little less on the Moselle than in the rest of the country, and the most optimal agricultural conditions can be found in the north of the country. Statistically speaking, animal production combined with fodder production are clearly the most important agricultural productions in Luxembourg. In recent years, especially after the abolition of milk quotas, the number of dairy cows has risen sharply. Probably more than in any other country in Europe. Suckler cow numbers have declined somewhat. Even if you look exclusively at the financial data over the last few years, you can clearly see that animal production plays a very important role. It is shown in red in the bar chart under income, and represents the largest input item from a financial point of view. An important point that leads to this situation is the large amount of permanent grassland in Luxembourg, which is undoubtedly best managed with livestock farming, and ruminants in particular. In terms of expenditure, feed costs are therefore logically in first place.
Here is the basic flow chart of CONVIS water protection activities. First of all, one must always consider the environment of the farm, i.e. geology and the structure of the farm in terms of arable land, grassland, and, of course, livestock densities. The farm is, of course, the focus. There is no question about that. One of the main tasks, in addition to the many and complicated rules that have to be observed, is to raise awareness and implement advisory knowledge on the farms. At the bottom of this slide, you can see the most important relevant topics, which are all addressed by the end of the presentation. Here is the flowchart of a new, quite recent program in Luxembourg, where the water protection areas are all accompanied by a kind of monitoring program. On the far left, you can see which actors are all members of such committees. The tasks of these programs are coordination between all actors of the drinking water supply and the agricultural sector, bringing together the elements of a program of measures, actual target situation, hazard risk catalysts, stakeholder analysis, program of measures. The elements are brought together in a regional framework, presentation and approval of the program of measures in the monitoring committee. Finally, the animator of this committee is also familiar with the implementation of the measures and the evaluation of such measures. The first drinking water pipeline in our country was put into operation on October 21st, 1866 in Luxembourg City, followed by Echternach, then the second largest city in the country, followed in 1876 by Esch, Alzette in 1885. Dijkirch built its first drinking water pipeline in 1909. Until the mid-1960s, the country's drinking water supply was ensured almost exclusively from groundwater, mostly from Luxembourg and Luxembourg sandstones, which are caught in the river basins, for example by the rivers Aisch, the Alzette, the Attert, or the Seer. In areas such as the Mullerthal or the Ike Valley, you can still find a large number of sources and wells or fountains that are used for drinking water supply. From 1969 onwards, the treatment plants and the supply lines of the Syndicate de Eaux du Barrage d'Esch sur Chur Sebes were put into operation, and thus surface water was used for drinking water production. The Sebes was created as a municipal syndicate with state participation due to its nationwide designation, unlike the other water syndicates with regional designation, by a law of July 31, 1962. The drinking water supply in Luxembourg is in public hands. The municipalities are therefore responsible for both the distribution of drinking water and the maintenance of the infrastructure. The total length of the Luxembourg distribution network is estimated to be more than 4,900 kilometers in the area of water supply. There are essentially three types of municipalities in Luxembourg. Municipalities that provide for themselves autonomously. Municipalities that are connected to a drinking water syndicate. Communities that have their own resources and are also connected to a drinking water syndicate. The last type about 35%, but the trend is rising. Groundwater resources in the Grand Duchy of Luxembourg are limited. Additional surface water is needed to guarantee the country's drinking water supply in the long term. In the 1940s, the Luxembourg government planned to build a large hydraulic structure as a drinking water reserve to meet the population's water needs. For this reason, in the 1950s, the government created the Lac de la Haute Chur. The Sebes was created by the law of July 31st, 1962, to reinforce the Grand Duchy's drinking water supply from the Esch-sur-Chur reservoir. The lake water undergoes a 7-stage treatment process at the Eschdorf treatment plant. At the end of treatment, the water meets the strict quality criteria for drinking water. It is distributed via the Eschdorf reservoir to Sebes water users. Later in the presentation, we will explain the water protection area of this lake. Water consumption in Luxembourg is around 120,000 cubic meters per day. According to the probable scenario demographic development in Luxembourg, water increased by 2040 to as much as 170,000 cubic meters per day. Currently, up to 2/3 of this water, some 70,000 cubic meters per day, are drawn from our groundwater reservoirs, the remainder being supplied from the Esch-sur-Chur Dam. The Luxembourg sandstone is the most important aquifer, accounting for almost 80% of national groundwater resources. It is a sandy geological formation made up of fine sand structured by limestone cement. Water circulates here mainly along the numerous fault systems and fissures that characterize this particular geological formation of our country. Luxembourg City, the south of the country, as well as the entire Mullerthal region, are replenished by this drinking water, supplemented sometimes by water from the reservoir. The procedure for designating protection zones is carried out in 3 phases. 1. A protection zone delimitation dossier is drawn up. This includes a hydrogeological study with proposals for the protection zone boundaries. 2. The delimitation project will be presented to the public. To the population concerned, any person concerned will be able to submit comments and any objections or appeals in writing to the College of the local mayor and aldermans. 3. The creation of a protection zone is governed by a Grand Ducal regulation. A specific Grand Ducal regulation defines the measures and restrictions applicable to the entire protected area. Specific measures in forest protection zones for groundwater catchments with particular properties will be specified in the Grand Ducal regulation establishing the protection zones in question. With regard to the definition of the different types of protection zones, the following can be said. Zone 1. In this zone, only activities intended for the maintenance and servicing of water extraction installations are permitted. As a general rule, this zone is to be fenced off and maintained as a green zone. Zone 2V1. This zone is particularly vulnerable and, above all, governed by prohibitions. Any work, installation, construction, or activity likely to affect the quality of the water resource is prohibited, including grazing and the spreading of fertilizers and/or pesticides. Existing works and constructions must be adapted as quickly as possible to ensure that any potential risk of pollution is reduced and kept to a minimum. Zone 2. Zone 2 is also governed mainly by prohibitions. Specific measures in Zone 2 concern, for example, restrictions or bans on the construction of new infrastructure pipelines, sewage treatment plants, and storage facilities for hazardous substances. Hydrocarbon tanks, for example. All new agricultural construction is also prohibited. The development of new residential, business, or industrial zones. The spreading of fertilizers and the application of pesticides are also subject to a series of restrictions or prohibitions. Zone 3. A Type 3 zone is governed for the most part by restrictions. New agricultural constructions, as well as the development of new residential, business, or industrial zones, are subject to ministerial authorization. Industrial zones are subject to ministerial authorization. The spreading of mineral and organic fertilizers and the application of pesticides are also subject to a series of restrictions and limitations. We are now interested in the economic situation facing our farms in Luxembourg in the area of water protection. In principle, the political financial support measures can be divided into two categories. 1. Market-based solutions. 2. State measures. The advantages and disadvantages of 1 are restriction of agricultural use only where contamination of drinking water sources is to be reduced. No effect against large-scale water pollution. The advantages and disadvantages of government measures are large-scale effect on groundwater protection, lower efficiency and effectiveness. We will now give you an overview of the agri-environmental and biodiversity programs in Luxembourg. This with particular emphasis on the financial situation. In addition to contributing to environmental and climate protection, the agri-environmental and climate measures are primarily aimed at preserving and increasing biodiversity, improving soil structure, and reducing fertilizer inputs. Participation by farmers is voluntary. As a rule, farmers and wine growers commit themselves for a period of 5 years. 4 important objectives can be summarized for the agri-environmental programs. 1. Contribute to climate change and mitigation and adaptation. 2. Promote sustainable development and efficient management. 3. Promote halting and reversing biodiversity loss. 4. Contribute to societal expectations. The following slide shows the 2023 agricultural budget for Luxembourg for the above-mentioned contexts. This budget can be divided into 3 main categories. 1. The direct payment including the new eco schemes. 2. The so-called compensation payments, which include, among other things, the direct water protection payments. 3. The AUCM programs. The payments for biodiversity programs are not directly included in this table. What is important here is that in each category a certain proportion, namely 42% of the budget, can be directly or at least indirectly linked to water protection issues. However, it is also important to note that water protection areas are not the only ones affected. Years ago, things were somewhat different. Agricultural Environment Program areas really had to be environmentally relevant. This is no longer absolutely necessary today. This is already a significant innovation in the marketing and presentation of such programs. This page provides an overview of these subsidies in tabular form. Each line in the table represents a separate program. The most important message here is that all programs marked in yellow can be directly or indirectly related to water conservation. As you can see, there is quite a high proportion of the programs that come into question. Nowadays, all these programs have to be applied for in digital form. Many farmers therefore need help from advisors from our organization, among others. There are currently between 10 and 15 CONVIS advisors actively working on farms in this area. A PDF document is also available digitally for each program, which contains detailed information on the exact conditions.
First of all, the GIS map should be mentioned here, which in itself reflects the organization of the biodiversity contracts in Luxembourg quite well. The fact is that biodiversity contracts in Luxembourg are organized either by nature parks or intercommunal environmental syndicates, depending on the area. In concrete terms, this means that the conclusion of such a contract always requires a certain type of approval from a competent expert from such an organization. Not all biodiversity contracts are directly related to water protection, but a number of them have at least an indirect positive effect on water protection. If there are restrictive overlaps with the agri-environmental programs, only the additional restriction is paid out. No condition or restriction is paid out twice. There are also really special things that are really intended for water protection, such as the construction of wooden bridges or fencing so that cattle really don't come into contact with the water in the streams around the reservoir. Incidentally, the biodiversity contracts are all still issued in paper form, not digitally. This is very different from the agri-environmental programs, and in some ways it can even be a kind of competition. Simply because certain groups of farmers see this as an advantage. On these slides we would like to explain the main input forms of our fertilization plan software. Firstly, we indicate for each livestock category whether the livestock are kept indoors on manure or on slurry and the proportion of pasture in summer, so that a theoretical amount of slurry and manure can be determined. It should also be mentioned that every farm in Luxembourg must submit a laboratory analysis of slurry and manure every 5 years, which is then also used in this context. Then, based on the area information from the previous year, the parcel data is updated, i.e. the size in relation to the area premiums, the actual usable size of each parcel and then the official FLIK numbers. This FLIK number, a digit in the form P0 followed by 6 digits, is relevant in relation to the annual subsidy declaration. The crops and catch crops are then entered, as well as the expected estimated final yield. The yield is of course quite important in relation to the expected withdrawal. Nevertheless, it only plays a subordinate role in planning. In addition, this form provides all information regarding the water protection situation and participation in programs. The next stage is the distribution of organic fertilizers. This is carried out as a function of the respective crops, the permitted periods of the year and the corresponding nationally applicable restrictions. At the same time, however, restrictions with regard to water protection areas must also be taken into account. Exactly the same applies to all environmental programs, i.e. the official agri-environmental programs as well as the biodiversity programs. It is also important to mention that every 5 years a valid manure and slurry analysis of the main nutrients nitrogen, phosphorus and potash must be carried out and the results of these analyses are used in the planning process. This gives this planning a certain farm-specific touch. In addition, the soil samples, which also have to be taken every 5 years, are also managed within this formula. The next stage is to define the mineral fertilization, but mainly the mineral nitrogen fertilization. Here, a whole range of all possible fertilizers are predefined in the DP12 software. Granulated but also often liquid nitrogen fertilizers are used. The level of mineral nitrogen fertilization is also carried out according to individual farm requirements. Direct discussion with the farmer and consideration of the entire farm situation is very important here in order to actually achieve the desired, positive environmental effects. On the far left of the form, the color coding function provides information on which parcel is registered in which agri-environmental program. Here is a brief explanation of the fertilizer app. The CONVIS app is a mobile application that has been specially developed for fertilizer planning and farm management. Here are some of the main functions of the app. Plot overview. It provides a detailed view and overview of all cultivated plots on your farm. Crop management data. All relevant crop management data is quickly and easily accessible. Fertilization planning. It provides an overview of the annual fertilization and plant protection measures. Mobile documentation. Measures from the first tillage to the harvest can be documented on the move. Reporting. It is possible to create and share plot passes and field reports as PDF files. The app can now also be indirectly linked to Google Earth mapping. The app is based on CONVIS fertilizer planning and enables precise and paperless recording and management of data. It is available in both the App Store and the Google Play Store and can be downloaded free of charge. It is also important to mention that an international situation very often has to be taken into account when planning fertilization in Luxembourg. Due to the geographical location, many farms cultivate some plots abroad, where the specific restrictions can be quite different in some cases. For this reason alone, the advisory service enjoys a very high reputation among farmers in Luxembourg, as it is not always easy to maintain an overview here. The tables on this slide show the different periods for the application of organic fertilizers in Luxembourg and in various neighboring countries.
Here is some information about another tool that is very important in the context of climate change and water protection and has recently been developed for Luxembourg conditions. It is an online tool that makes it possible to decide, as a function of the weather over a period of approximately 2 weeks, whether plant protection measures really make sense or not. Aspects of the economic damage threshold are also taken into account. The tool is available for herbicide and fungicide treatments. In terms of climate technology, the latest findings on, for example, fungi resistance from the more southerly regions, in this case France, as well as local temperatures and rainfall are also taken into account. These tools are explained to farmers as part of the regular mandatory training for farmers as part of their phyto license. The use and application is not always so easy, especially for a new first-time user. These tools naturally have a direct positive influence on the water topic.
Hello, first of all I want to show you our Luxembourgish GIS system on the GeoPortal and see how the whole system works. First of all I click on the FLIK parcels. This is a single block for the whole country, and then the numbers that are actually relevant for the agricultural subsidies are immediately displayed. Then there is a search function that you can use to search for a specific village, for example, and then you can display fields. I deliberately chose Schengen here to show him a bit of the vineyards on the Moselle, but not least because it lies between Luxembourg and Germany, exactly the place from which this important European Schengen Treaty on the free movement of persons was signed at the time. Yes, the world is sometimes very small. Here comes the actual presentation of the water protection areas on the GeoPortal. I will first click on all the different areas separately. The aim here is to distinguish between areas that have been designated, areas that have been provisionally designated, and areas that are being planned for designation. In addition, the reservoir on the upper western edge of Luxembourg is also shown. It is the only real surface drinking water protection area in Luxembourg. The metazacular prohibition zones are shown in red. The blue zone at the reservoir area is the direct zone, which is virtually at the water's edge. The various other colors for this reservoir show further specific subdivisions of these surface water protection areas. This is particularly related to the gradient of the topography.
This video shows you how the water protection zones are displayed on the GeoPortal. It is nice to see that there is a color marking depending on the zone. It is also important to note that there are different categories in the designation procedures. Some areas have already been properly designated. Others are in the process of being designated, and then there is another category that is currently provisionally designated. The GeoPortal offers the possibility to adjust the color tones. This allows the user to see exactly where the water protection area really goes. It should also be noted that there is always a direct link to Legilix for the water protection area. All water protection areas are stored on Legilix as a Grand Ducal regulation. There is a separate ordinance for each area, and the agronomic restrictions can also vary depending on the area. In addition, each area is defined with a map on Legilix. All information from Legilix can also be downloaded as a PDF document. Important here is, as already mentioned, the area-specific restrictions as well as the map that is stored. It is important to know that in the legal procedure for water protection areas, the correct cadastral parcels are recorded and not the so-called FLIK parcels, which play a role in the annual subsidy declarations. This is another problem for the agricultural consultancy, as the cadastral parcels, which are often centuries old, no longer correspond to the current FLIK parcels. But only the cadastral plots are legally valid. On the far right of this slide, you can also see the desired timeline in the area of water protection in Luxembourg, of course with a direct link to the European directives, which must be implemented locally.
The Soil Science Department of the ASDA, Administration des Services Techniques de l'Agriculture, has been responsible for drawing up various soil maps for Luxembourg since the 1960s. These maps help to characterize the soils in terms of their agricultural and forestry production potential. However, this information is also very important in the area of water protection, because the risks are assessed differently depending on the soil type and different conclusions can be drawn depending on the situation in the event of problems. The National GeoPortal of the Grand Duchy of Luxembourg offers numerous maps and data on geographical topics, including soil information. The Soil Science Department of the ASDA has developed a 4-level classification of soil erosion risk for agricultural land in Luxembourg. This classification is available on the National GeoPortal site and helps farmers to adapt their practices accordingly. The 4 risk levels are: 1. Very low risk, 4% of agricultural land. 2. Low risk, 19% of agricultural land. 3. Medium risk, 6% of agricultural land. 4. High risk, 2% of agricultural land. This map was created to help farmers take appropriate measures to control erosion, such as the use of protective plants, the selection of suitable crops, and the reduction of soil erosion. As part of the annual area declaration for agricultural subsidies, erosion strips must be created in the 2 upper tiers. In parallel, this appears to be a very sensible measure for the area of water protection. At the end of the video you can get a graphic overview of how many of these plots appear where in the end. The erosion mapping in Luxembourg is based on the revised Universal Soil Loss Equation (RUSL) model, which is used to model the risk of erosion. In addition, aerial photographs from the last 10 years were used to check the plausibility of the erosion and to classify the arable plots at risk into 4 levels. In any case, the final result is a kind of index. Farmers can initially also make public complaints, and then critical plots can be reclassified manually. It seems that the current system often incorrectly classifies even larger arable fields of land, for example, and farmers are wrongly instructed to take measures in various cases. Biotope mapping in Luxembourg is an important part of nature conservation. It includes the recording and evaluation of protected biotopes, both in open land and in forests. The results of this mapping form the basis for nature conservation and forestry planning. Since 2007, a nationwide survey of biotopes protected under Article 17 of the Luxembourg Nature Conservation Act has been carried out. The mapping of landscape structure elements, LE, in Luxembourg is also an important aspect of land use planning. Farmers and winegrowers can submit applications for the creation, modification, or deletion of LE or non-productive areas, NPF. This information is recorded in the Graphic Parcel Reference System and is used to ensure the eligibility criteria for area-based aid. All of this information can be important in the area of water protection, as it can also be used to stop erosion.
This slide now shows the possibilities of the Digital Elevation Model BDL Leader, which is based on data from 2019. First of all, we have an elevation model for the greater region of Luxembourg with alternative color representation. Furthermore, we can see a digital surface model, a digital elevation model, and a digital elevation model with alternative color representation. On the far right of this slide, you can see the legend, which shows the respective height above sea level on a technical scale. This data can be used for very different purposes later on. It can be very useful for agriculture. For example, such maps are used to issue special permits for liquid manure spreading in January 2024. This slide now shows examples of these special permits from last year. The whole thing works as follows. The farmer shares some possible Here is another application of these map systems. Here you can see the example of a municipality from Luxembourg, where this data has been processed by us with the QGIS software. The blue polygons show the different water protection areas. The red polygons show the boundaries of the municipality. All required data can be downloaded either directly from GeoPortal or from the linked web page Data Public. In principle, this data is available to all consultants. It is important to note here that the source versions are of course selected at strategic points. Of course, this always requires a rather complex special study, but you can already see here how the spring tappings are selected as a function of the terrain gradient. In the video you can see the blue water protection area on the right of the map, the corresponding valleys exactly as visible on the GIS map, and then in this case the fence zone 1. In this case a deep borehole and not a direct spring tapping. Morphometry is an important tool in geospatial mapping because it quantitatively describes and analyses the geometric properties of the Earth's surface. Here are some reasons why morphometric information is needed. 1. Relief shapes. Morphometrics helps capture the shapes and features of relief, such as elevation differences, slopes, and curvatures. 2. Hydrological modeling. It is crucial for the creation of hydrological models used to predict flood events and to model the material balance of river catchments. 3. Erosion risks. Erosion risks can be better assessed by analyzing terrain slopes and other morphometric data. For infrastructure planning, morphometric data is important for planning infrastructure projects as it helps to identify suitable locations for roads, bridges, and other structures. 5. Environmental monitoring. It supports the monitoring of environmental change by providing data on changes in landforms. Two of the 5 shown are, for example, exposure and slope. Both are important terms in geomorphology and geomapping, but have different meanings. Exposure. Definition. Exposure refers to the orientation of a surface or slope in relation to the cardinal directions, north, south, east, west. Meaning, exposure affects how much sunlight an area receives, which impacts vegetation, soil development, and microclimate. For example, a south-facing slope in the northern hemisphere may receive more sunlight, and therefore warmer temperatures than a north-facing slope. 2. Slope gradient. Definition. Slope gradient describes the angle or steepness of a slope in relation to the horizontal, usually expressed in degrees or percent. Meaning, slope gradient is critical for assessing erosion risks, landslide hazards, and water runoff patterns. Steeper slopes are more prone to erosion and can pose challenges for construction projects and agriculture. To summarize, the exposure describes the direction in which a slope faces, while the slope gradient indicates the steepness of this slope. Both factors are crucial for understanding the landscape and ecological dynamics of an area. Overall, morphometry enables a detailed and precise analysis of the Earth's surface, which is essential for various geoscientific applications. Luxembourg's Water Management Administration, AGE, has created heavy rain hazard and risk maps that are accessible via the public geoportal. These maps are intended to help municipalities and farmers recognize and reduce the hazards and risks of heavy rainfall events. The maps show the potential hazards from surface runoff, including the depth of flooding and flow velocity. They were created using the flood area model, which combines rainfall runoff modeling with a 2D simulation of surface runoff. See in particular the colors of the legend on the right as a function of water depth and flow velocity. These maps are part of a national heavy rainfall risk management strategy that was developed after the devastating heavy rainfall events in 2016 and 2018. The aim is to provide municipalities with tools to assess the risk of heavy rainfall themselves and to plan preventive measures, but also to highlight hazards. After all, a map is intended solely for the hazards.
Many projects are currently underway across the country at municipal level to manually refine the machine-calculated heavy rain hazard maps. This map here shows a case of a municipality that we have already seen several times on the mini videos on the previous slide. You can calculate here that a study for a municipality of approximate 3,000 inhabitants, for example, costs approximate 60,000 year due to climate change. The state authorities are making the construction of such systems really expensive. However, there is also a certain amount of public pressure due to recent floods that such warning systems are set up.
We also wanted to take this opportunity to benefit from the fact that we are carrying out what is known as sustainability monitoring for a whole range of our members who also have land and water conservation. This is essentially about balancing and evaluating the input-output balance of the material flows of an agricultural farm. In the context of today's presentation, it is very important to mention that a large part of the evaluations in connection with this tool are related to nitrogen management. Nitrogen is of course one of the three problems in water protection, along with bacteria and plant protecting products. It would go too far today to present the whole tool, but we will certainly have the opportunity to do this another time as part of the CSA project. After all, this is not just about nitrogen, but also about all the climate-relevant emissions and, to some extent, economic issues. Today, to conclude the knowledge exchange event, we would like to show you a short video that describes the activities with this tool very well in just a few minutes.
The Earth's population is constantly increasing. At the same time, cultivated areas are getting smaller and smaller. This forces the agricultural sector to use these limited resources as effectively and efficiently as possible. Responsible and sustainable action is needed here. However, this can only work if the farm's environmental footprint and energy balance are measured and evaluated in a precise manner. CONVIS, the Agricultural Cooperative for Animal Breeding and Advisory Services in Luxembourg, has developed an effective solution for sustainability monitoring. Based on accounting documents, it is now possible to calculate nutrient pollution, energy efficiency, and greenhouse gas emissions in no time at all. Information input such as data on required resources is compared with the output produced. The results provide the farmers with specific approaches on how to improve their environmental performance in terms of soil, water, air, and energy, and still save money. Policymakers are now able to define environmental goals and support the agricultural sector more effectively. The retail sector benefits from the possibility of providing consumers with products that reliably integrate the environmental dimension. This enables consumers to make a direct contribution to protecting the environment when purchasing a product, for the sake of our society and our environment.